Okay, I'm going to take one more multiplication of polynomial example. I'm going to try to use one of the shortcuts that's outlined in the book. You could multiply the 3x by all three of those, 2 by all those, 5y by all those, combine them, and that will work fine. But sometimes you can find shortcuts that can save you a little bit of time. One of the patterns we have is if you have a number or term plus another term in a binomial multiplied by the difference of those terms, that turns out to be, after you've done the simplification, a squared minus b squared. It looks to me like we can apply this pattern to the polynomial up here. If we treat 3x plus 2 as a, and we can see we have 5y minus 5y there, and 5y at b, here would be a again, and this would be b. We do have that pattern, a plus b times a minus b. So what we should be able to do is just square a and then square b and subtract it from a squared. So multiplying those two polynomials, I should be able to do this as 3x plus 2 squared minus 5y squared. So that's the way I'm going to do this. I'm going to multiply these out and see what we get. When I square 3x plus 2, that's 3x plus 2 times 3x plus 2, you get that. Here we're going to have minus, and when we square this, we're going to have 25y squared, so it'll be 25y squared. So I'm done with that term. But let's multiply these two binomials out. 3x times 3x, you get 9x squared plus 6x plus 6x plus 4. And we still have the minus 25y squared. We can combine these two terms, and so we end up with 9x squared plus 12x. I'm going to put this next, minus 25y squared. I'll put the constant term on the end. So that's one way to write the answer. Sometimes you'll put the y squared term after the x squared, but that's somewhat arbitrary. So that's using this shortcut, which is a handy shortcut to make the multiplication of those polynomials quicker.